welcome. Here we have an interesting u substitution integral. And what makes this interesting is that it doesn't look like a u substitution. In fact, it looks like you might want to use integration by parts or another method of integration. But really, u substitution is the best way for solving this. So to start out, we want to simplify this radical. So we're going to say u is actually just going to be x squared plus 1. So our du, or the differential du, must be equal to 2x dx. We have to solve for this differential dx. So we get dx is equal to du divided by 2x. So now this leaves us, and after we plug in du 2x over 2x for dx, we get x cubed times by the square root of u divided by 2x dx. Well, this x and this x cubed will cancel, leaving behind an x squared, and we'll pull out the 1/2 outside the integral. So this is what our integral is looking like, but we cannot integrate x squared with respect to u. So what we're going to do is we're going to actually solve for x squared in terms of u. So u is equal to x squared plus 1, so x squared must be equal to u minus 1. So we get 1/2 the integral of u minus 1 times by the square root of u, du. We can now expand this out, so we are left with 1/2 the integral of u to the power of 3/2 minus u to the power of 1/2 du. Now that these are in a calculus-friendly form, we just have to raise the power by 1 and then multiply by the reciprocal. So we get u to the 5/2 times by the reciprocal, which is 2/5, minus u to the 1/2, or sorry, u to the 3/2 times by the reciprocal, which is 2/3, plus c. Now all we have to do is divide this 1/2, leaving behind 1/5 and 1/3, and then plug in our u. Our u is x squared plus 1, so we get x squared plus 1 raised to the 5/2 minus 1/3, or sorry, 2/5 minus 1/3 x squared plus 1 to the 3/2 plus c, leaving us with the answer of 1/5 x squared plus 1 to the power of 5/2 minus 1/3 times by x squared plus 1 to the power of 3/2 plus c. And that is our answer to this integral.